Hello, everyone. Thank you so much for joining us. Just to let you know, we'll start the presentation in about 1 minute. Hello, once again, everyone. Just to let you know, we'll start the presentation in about 30 seconds. Thank you for joining us. Well, an official hello, everyone, and welcome to today's Safety and Health Magazine webcast, NFPA 70B, focusing on maintenance of electrical equipment, sponsored by OEL. This is Alan Ferguson. I'm Associate Editor at Safety and Health and co-host of the On the Safe Side podcast, and I'll be moderating today's event. Thank you once again for joining us. And before we get started, there are a few housekeeping items. As a disclaimer, the views of today's speaker and organization are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication does not mean the magazine the council endorses those items. After today's presentation, we'll conduct a question and answer session with our speaker. If you have a question, click the Q&A button at the bottom of your screen, type your question, and press the send button. We welcome your questions at any time during today's event. You don't have to wait for the Q&A to begin. We might not get to every question, but the good news is unanswered questions will be forwarded to today's sponsor. Also, after this presentation, you'll be asked to complete a brief evaluation survey, and I'll tell you more about that a little bit later. Also, just to let you know, this webcast will be archived so you can access it after today's live event. To view this webcast and all of our past webcasts, please visit safetyandhealthmagazine.com/events, so you may also receive a link in our post-event email. With that, let's introduce today's speaker. With us today is Derek Vigstall, electrical safety consultant for eHazard. Derek has been with eHazard since 2021 and was previously with the National Fire Protection Association for 6 years as a senior electrical specialist, an electrical technical lead, and a senior electrical content specialist. He was a subject matter expert for the development of the entire training suite for the 2020 National Electrical Code and was a technical reviewer for the 2017 NEC and 2018 NFPA 70E training products. Derek is also the primary author of the 21st edition of the Electrical Wiring Residential Textbook. Additionally, Derek has been an instructor at Minneapolis Electrical JATC and owned a home inspection business. Derek, whenever you're ready, go ahead and take it away.
All right, thanks, Alan. So welcome everybody. Today we're going to be talking about NFPA 70B. This is one of those documents that's kind of near and dear to my heart. I'm one of those self-proclaimed code nerds out there. So anytime a new standard or a new revision of a standard comes out and there's some changes to it that we got to talk about, I get a little jazzed up. So I apologize if I get a little over the top here on the excitement scale today. But I really enjoy talking about 70B and the impact it's going to have on the industry. So a little bit about how the presentation is going to go. We're going to look at, number one, what is NFPA 70B? Because I still get a lot of people when I go out and do presentations that really aren't all that familiar with exactly what 70B is telling us to do. We'll look at how the regulations, especially with OSHA, and how all of that plays into the maintenance conversation. And then we'll also look at the impact that 70B shifting from a recommended practice now to a full-blown standard is going to have on the electrical safety and the electrical industry in general. And then we'll look at how is this going to improve electrical safety. These are all big questions that we have to answer. And in there too, I'll sprinkle in, how 70B is structured, how it really works nicely to help an employer, or really it's not so much about the employer anymore as it is about equipment owners, and how it helps those folks draft up this big concept of an electrical maintenance program that we have to make sure that our equipment is safe to work around, make sure our equipment is reliable, make sure we minimize our downtime and maximize our safety impact. So with that, let's jump into it. So the first big question we got to ask is, why do we do electrical equipment maintenance? And this is one of those kind of things that's been a little bit hit and miss in the industry over the years. You've had people who do a fantastic job of maintenance because they read the manufacturer's instructions when they got that new piece of gear or whatever it happened to be. And so they do absolutely everything that they're supposed to do. So the good news for those folks, you're already doing it. So 70B isn't a huge blip on your radar. But for a lot of the industry, that gear was just this big gray box that sat in the corner of a special room that only qualified people were allowed to go into. And they didn't really look at it as having all these moving parts and stuff inside there. So maintenance necessarily wasn't a big part of their equation. And they basically treat all of their electrical equipment the way we treat a light bulb at home, is let it run until it burns out and we'll replace it when it's broken. So we got to kind of look at how do we shift that narrative and shift it into something that's a little bit more proactive in keeping our workers safe in the electrical industry. And really, if we look at the OSHA requirements, we can see not necessarily that OSHA is saying, oh, here's the steps you have to take from a maintenance standpoint, but we have all of these requirements from a safety standpoint in OSHA saying, we got to de-energize equipment, we got to be careful when we're working around electrical hazards, and we got to make sure we're wearing the right PPE and all that stuff. But the big one that really kind of tips its hat that we got to be doing this maintenance stuff is all the way back at that general duty clause, right? It is the duty of an employer to provide their employees with a workplace that is free from known and recognized hazards. And even though we may not be able to get it 100% lock, stock, and barrel free from electrical hazards in the workplace, we got to be making an effort to get as close to that ideal as we can possibly get. And so the general duty clause, the way I view that is really looking at that as kind of the purpose statement of OSHA to say, okay, we want employers to get as close to free from recognized hazards as possible. And so how do we do that without maintenance, right? We need to know our electrical equipment is going to do the thing that it needs to do when we need it to do that thing. So if we aren't doing maintenance, it's pretty hard for us to kind of comply with that. And so it really becomes the same conversation. Like, even though OSHA doesn't have the smoking gun requirements in there that say you have to maintain your equipment and here's how you do it, it has that big umbrella statement saying, hey, we got to do everything within our power to provide that a safe workplace to our employees. So really, just like with 70E, OSHA is saying, here's what we have to do. And that NFPA suite of consensus documents is really going to tell us how to comply with that stuff. And so even when we look at NFPA 70E, 70E is the compliance strategy, the industry consensus compliance strategy with say subpart S in OSHA 1910. Well, so much of 70E is really going to be based around both the proper installation and the proper maintenance of electrical equipment. So 70B is as big a part of conversation when it comes to compliance with OSHA as 70E is, because you can't have 70E without having a good maintenance approach to your electrical equipment. So it 70B is going to fit right into that same sort of bucket as 70E is, and it's all part of the same conversation of compliance with OSHA. So let's look a little bit at how 70B came to get to the point where it's at today. So little known fact, outside of all the code nerd circles that I run in, 70B is actually older than NFPA 70E. It was actually a committee formed in the late 60s when there was a lot of requests and public inputs, or back then they were called proposals, but there are a lot of proposals coming into the NEC around electrical equipment maintenance. And so the powers that be over at NFPA at the time really got together and started looking at, hey, is this worth forming a committee to draft up a full-on document on how to do electrical equipment maintenance? And so that's how the recommended practice for electrical equipment maintenance was really born back then, was out of this abundance of proposals coming into the NEC around how do we maintain our electrical equipment. And so that was the birth of 70B, but it kind of lived in that space for a very long time as being this recommended practice. And And when I was at NFPA, the internal joke there was kind of, well, it's 300 pages of you should go read the manufacturer's instructions, and which wasn't too far off from what it really was, but there was a lot of really good stuff in there, and it really helped advertise the reason why equipment owners should have their own electrical equipment maintenance program and really should be paying attention to maintaining this stuff. um, the problem is not a whole lot of people knew about it. It was a recommended practice, so it wasn't really written in mandatory language. It was a bunch of shoulda, woulda, coulda stuff, and it wasn't really ready yet if it got thrust into the prime time. And we had this conversation, I know internally, pretty much from day one when I went to NFPA. There was a whole lot of discussion around shouldn't 70B act as a bigger part of the conversation when it comes to the three-legged stool of electrical safety, which is the NEC 70E and 70B. And so I went to a couple of committee meetings, and it really, the question was kind of asked around, hey, if 70E or if OSHA made maintenance a 100% requirement, you have to do this kind of thing, would 70B be ready to step into that role and be ready to take on that responsibility? And I think it was overwhelmingly the committee looked around the table and said, I don't think we don't think it's quite ready for it yet. So we need to take a look at moving it forward to a full-blown standard. And of course, NFPA's electrical section got together and they said, yeah, I think this is definitely a move that would be good for the industry. And so now we've kind of solidified that, like I said, that three-legged stool of electrical safety at NFPA. We have to install it properly, we have to maintain it properly, and then we can work on it safely. And really 70E makes assumptions that our equipment that we're going to go work on has been installed properly, it has been maintained properly. Just look at the language in the normal operating condition piece where it talks about, we, in order to consider something in a normal operating condition, it has to be properly installed and properly maintained. So right there gives you kind of 70E's approach to when we work on equipment. All of these assumptions we're going to use to keep employees safe are based on those two concepts just right out of the gate. So if we drop either one of them, kind of the ball's up in the air, and it's a kind of big question looming out there: is this really safe to work on? And so we need to have all three of those pieces to it. And it was more than just to move this from a recommended practice to a standard. It was more than just, well, let's go change all the shoulds to shalls, and that'll accomplish what we're looking to do. They really had to rethink, how is this document structured, and all of that great stuff that existed in the previous edition when it was a recommended practice. It took a lot of hard work and a lot of time and energy from the committees going back all the way to late 60s. They didn't want to lose that kind of information. So they kind of said, okay, well, some of this stuff is annex material, some of this stuff is really good, it could become a requirement. And so they really had to take a step back. And if you were one of the folks that knew about 70B, you kind of noticed that they went from a 2019 edition to 2023, which means they had to take a whole extra year in the revision process to get it right. And I think it's got a good structure to it. Is it where it needs to be 100%? Is any standard ever at 100% finished? That's why they get together every couple of years to kind of do these revision meetings. So it's not 100% to where it's going to get to, but I think it's got a good start, right? And it really helps to provide equipment owners with this plan to say, hey, how do we build out a maintenance program? And then once we have this EPM, what they refer to it in 70B, once we have that in place, then we're going to look at, making sure we train people on what that program entails, making sure we follow that program, making sure we set our intervals right, and do all that stuff. And it really helps us fill in the gaps where we had on maintenance. Now, when we look at the structure, this is going to be a little different for all my NEC and 70E folks. The format in 70B actually follows the other NFPA style, which is referred to, the NEC and 70E follow the NEC style manual, NFPA manual of style format. it's a little bit different. So we have some things that are always going to be in the same spot. The admin stuff, scope of the document, application of it, reference publications is going to always be chapter 2. Definitions is always going to be chapter 3. And we'll always find that stuff up in the front of the book. And then this is also the format that follows okay, I've got definition is in chapter 3. So the first number of the section is 3. Then if it's an NFPA 70B specific definition, that's going to be in section 3 of chapter 3. And so it's 3.3, and then whatever number definition is the next dot number. So 3.3.31 would be a specific definition to 70B. And you might have some sections that are, chapter 9.2, so it's 9.2.2.4. And so this is the bigger format that kind of follows along with all the other NFPA codes and standards. But I really like the way they laid this out. And like I said, it's really about understanding when we need to, what intervals we need to put things at, and what certain type of tasks that we need to do and when we need to do them. And they laid it out pretty well. I really like the format of it because it just kind of makes sense when you get into it. So like I said, the early chapters 1, 2, and 3, these are always going to be the same. The administrative chapter in chapter 1, that's going to be like the scope of the document. What does 70B apply to, and looking at the application of it, and how do we put this into practice? And really, like I said, the main point of 70B is in giving equipment owners a standard on how to build an electrical maintenance program. So we'll look at that and go through that in chapter 1, but it's kind of basic boilerplate information other than the scope of the document. We want to make sure we're following the scope of the document and understand what it applies to. Number 2 is reference publication. So there you'll find things like different UL standards and different, maybe a NETA standard that they're going to refer to. Rather than put the references throughout the whole document, they put all those reference documents up in chapter 2. So if we have a document we want to reference in the maintenance world, we'll find that list of publications up in chapter 2. And then we have chapter 3, which, like I said, is our big definitions chapter. And that's where we're going to find all definitions. We have some that are general NFPA definitions that apply across several different standards. But the big focus really is going to be on chapter 3, the NFPA 70B specific definitions. That's going to help us understand how to interpret different requirements within the standard. And then we move into chapter 4, and this is the big one. This is our general chapter. We're going to look at basically, defining who does what, how do we build the maintenance program, and really kind of crafting that star of the show. Because we got to remember this with whether it's 70E, 70B, any of these documents, they're industry consensus standards, and they have a huge umbrella scope that covers a lot of different parts of the industry. And so they can't ever come up with, here's a set of requirements that covers every single workplace to a T, all down to the specifics, right? So that's why 70E requires that we create an ESP, or electrical safety program. 70B is going to require, hey, you need to build an electrical maintenance program, or EMP. I think I said EPM earlier, misspoke there, but EMP is what the star of the show is going to be here when it comes to our maintenance stuff. And that's where we're going to define the different personnel roles. We'll talk about qualified persons. We'll talk about this role called an EMP coordinator, who's basically going to be a lead role that gets into developing the program, maintaining the program, auditing the program. So this is going to be this pretty important role when it comes to maintenance coordinator, the EMP coordinator. And so we'll look at what the EMP needs to include. We're going to have a reference somehow, some way, or even make it a part of the electrical safety program. And we're really going to those two are going to work together really to help define that condition of maintenance that becomes such a big part of the conversation on the safety side of things. Is the equipment serviceable? Is it something that needs a little bit of TLC, or is it something that's so far gone that we just have to completely replace this thing, like, the light bulb that's burnt out needs to be replaced, kind of thing. So we're going to use 70B and our specific maintenance program that we draft up to kind of help us with that assessment. Okay, we're also going to look at uh, this concept of creating a sort of maintenance analysis of our electrical equipment and going through and assessing the equipment we have. What state of maintenance is it in? What needs, maybe some equipment is in a state where we need to up the frequency with which we would do maintenance to it. Or some of the equipment, like I said, is non-serviceable, so it really needs to be tagged for replacement as quickly as possible. And then we're going to document all this stuff, and through that documentation, we can track it. We can make sure that we're staying up to date on things, and we can even kind of shift into more of that predictive maintenance, which I'm going to talk about a little bit later here in the program. It'll also come up with our plans for doing inspections, servicing, and the different tests that are required by 70B. And when we get into the specific chapters that apply to each of the specific pieces of equipment that we deal with, I think that's where it really shines, is the way it's laid out. We'll have an interval chapter in chapter 9, which talks about, okay, you do electrical tests, every 12 months or every 3 years or something like that. And then when we get to the specific chapter, it tells us what are those specific electrical tests that we need to do with each piece of equipment that falls under that. So when we take this equipment specific chapters, we couple that with the chapter 9 stuff, and then we can kind of come up with building our own schedule and our own plan for how we're going to do maintenance going forward. And then we're also going to have in that EMP, we're going to look at, structuring our corrective actions and how to get into, how do we make this better going forward? How do we bring it back up to the original operating condition? That's ultimately where we want to be in, because there's no equipment out there that's as safe as it was on day one when we fired it up, right? So we want to get equipment back up to those standards and keep it there, both from a reliability standpoint and from a safety standpoint as well. So the EMP is going to really detail out how we're going to follow this. Now, if you have manufacturer's instructions still available for your equipment, great. Use that information to structure your EMP. Okay, the manufacturer's instructions are always going to trump everything. Where it gets into a little bit of a kind of sticky situation between 70B and the manufacturer's instructions is when we start looking at things like, well, we purchased this building and we have no idea what anybody else did for maintenance before us. So that's where it gets a little tougher to say, okay, do I follow manufacturer's instructions here, or do I have to follow a 70B program and follow the intervals in 70B? Excuse me. But we have to look at it from that standpoint and see, which one is the more accurate one to follow, because I may have manufacturer's instructions, but this equipment's 40 years old and I have no idea what was ever done to it before. Following those manufacturer's instructions aren't necessarily going to get me back to that original operating condition that I'm striving to do. So I may have to start with 70B and get a couple rounds of maintenance under my belt to really look at, once I've got a couple rounds or a couple cycles of maintenance and I'm not identifying any outrageous issues that are coming, then I can kind of go back to that manufacturer's instructions requirement. Now, if I don't have manufacturer's instructions, then really all I have to fall back on is the 70B requirements and follow the process in 70B. Okay, so that's really how it's kind of designed to do. And there are other things. I mean, if we're using NETA contractors or something like that to come in and do our maintenance procedures, well, they're going to be following NETA MTS, which is another standard altogether, which kind of specifies the different maintenance procedures that those maintenance contractors have to follow, tells them how to do the test, tells them what the results of the test mean. So NETA MTS is also a big part of the conversation as well. Now, chapter 5 is going to move into talking about the qualified person aspect of it. And so just like with 70E, we talk about anytime we're doing work that exposes an employee to an electrical hazard, we want to be using a qualified person to do that. And so the definition in 70B is going to be identical to the definition in 70E, in that a qualified person is somebody who has demonstrated their skills and knowledge related to the electrical equipment and installations, and has taken the necessary safety training to be able to identify hazards present in their work and avoid any risk or reduce the risk that's associated with those tasks. Of course, I'm adding a little bit of my stuff to it. If you go read the definition, a little bit more tight in the way they define it, but basically what they're saying there is, in order to be a qualified person with this, number one, you have to know what you're doing and the equipment you're doing it with, and you also have to have had safety training to be able to anticipate when hazards are going to be present in your work, and to be able to take the necessary steps to mitigate those hazards, right? This is all kind of part of that safety cycle, right? Maintenance and building programs and the electrical safety program, providing training, making sure that the people who are doing this work are indeed qualified to go out there and do that. And the big part with the maintenance qualified person is it really is going to boil down to them being qualified on the task that they're being given to do. So if I'm going in and taking an IR scan, well, just knowing that a shock or an arc flash hazard is present when I do that isn't enough necessarily to make me qualified to take an IR scan. I also have to know how the IR equipment works and what to take pictures of and all of that stuff. So a little bit of an added complexity to the definition of qualified person when we get to the maintenance side. Okay. It's also going to, and this one, this whole chapter 6 is absolutely one of my favorite, because it puts into there the importance of maintaining our documentation. Okay, making sure our one-line diagrams stay up to date, making sure our short circuit studies and our incident energy analysis, our arc flash studies, making sure they stay up to date. And so we're doing that revision or review of those documents on the every 5-year cycle, and that 5 years is in 70B and it's in 70E. So they kind of harmonize there with each other, and we don't have one document requiring we do it at a different frequency than the others. But it's really to make sure that when we go to work on this stuff, we know that our risk assessment results are going to be accurate, because we're staying up to date with that kind of stuff. And then also talks about documenting and keeping the different studies up to date. If we have any sort of equipment in there that falls under the safety by design piece, or all of that document, and maintaining that documentation so that we know that that what we need to do, what we need to happen when we're doing the work is going to happen. Okay, so it's a big part of the equation. So I like chapter 6, because I don't know how many times as a service electrician I walked in the door and I asked for one-line drawings, and I get this really blank deer in the headlights look from the facility manager saying, what are one-line drawings? Like, well, it's just where I need to start, but we can work past that. All right, chapter 7 is also going to be basically there's certain fundamental tests, IR scans, bolted bus connections. You're going to see those throughout the specific requirement chapters when we get, chapter 10 through the end of the book, where it gets onto specific equipment. You're going to see things like IR scans, bolted connection resistance tests, insulation resistance tests. So those are basically kind of universal across the board. If you think about it from a standpoint, if you were doing just these basic things from a maintenance standpoint, it's already going to put you leaps and bounds up above where we were at, right? So if we just set it and forget it in the corner of the room, we're going to get we would expect one result from the lack of maintenance. But if we were just doing some basic things like IR scans and resistance tests and stuff like that, it's going to put us, like I said, leaps and bounds above where we would be if we didn't do anything. And then chapter 8 is where the rubber starts to meet the road here. So we get into what we call special hazards risk assessment. And this is really getting into looking at what is the condition of our equipment. And when we go out there and we start looking at providing the tests that 70B is going to require we do, some of this stuff may be serviceable, some of this stuff might not be serviceable, needs to be replaced, or maybe it has limited service. So it's, we gotta restrict what we can do with it. It's also going to define what the different category types are. So when we get into the specific chapters, you'll notice in their tables in those specific chapters, it'll have a whole list of things that we have to do, and then it'll tell us the test type. Is it a type 1 or is it a type 2 or 1A or 2A? So basically type 1 being an online test, meaning it's energized, type 2 being an offline test, meaning it's de-energized. When you see the letter A added to the number as far as test type, that's just going to be an enhanced one, which means this is something that's above and beyond what we normally do for equipment like that. So there's some things you have to do, some things that are kind of more optional, just puts us in a better place. So chapter 8 really defines that, and then also talks about the personnel qualifications, going back to that qualified person conversation. And then we talk about the condition of maintenance. And here's where it really comes down to labeling the equipment. Is it serviceable, limited service, or is it non-serviceable? And serviceable means that everything's working like it should. We may still have to do maintenance on it, but it's equipment that can keep functioning and doing its job. Limited service is a little bit more, like I said, dialed back. It maybe has some active indications from a PM that show that something needs to be fixed, but we don't have to fully replace the entire piece of equipment, because maybe it's just one bearing or a cooling fan or a space heater or something like that that's got some issues. So we should hurry up and get that component of it fixed, but we don't have to come in and full scale replace. Whereas the non-serviceable equipment's a little bit more on the serious side, where this is in a state where it is now total failure is imminent. We need to get in here and correct this ASAP, or we're going to have a situation where the equipment has failed, and now we're in a world of hurt, right? And that's really what we're trying to avoid, both from safety and reliability standpoint. Because let's face it, nobody that owns electrical equipment wants to have down production time or downtime in their store or whatever it happens to be because their electrical equipment failed on them, right? So that's a big part. Reliability is a big part of maintenance as well, but we're going to add to it the safety conversation too. All right, chapter 9. And here I think chapter 9 might be the star of the show when it comes to 70B. Unless you have the manufacturer's instructions. Again, if you have manufacturer's instructions, the equipment's in good working condition, serviceable equipment, default back to those intervals of what the manufacturer is telling you to do. It's kind of like when you change your oil in your car, right? So all these new cars, manufacturers are telling, okay, you gotta change your oil every 5,000 miles now. But I'm a farm kid from Minnesota, right? So my mentality has always been every 3 months or 3,000 miles, whichever one comes first, usually the 3,000 miles. That just happens to be my brain. And so getting into this, waiting for the car to tell me, hey, change the oil, a little bit outside my comfort zone. So it's like, maybe the manufacturer's instructions say you could go every 7 years, but 70B is telling you to do it every 5 years. It's not bad to follow 70B, but it wouldn't be inappropriate to follow the manufacturer's instructions either. I would say go with whatever is the tighter maintenance interval, and that's going to help you improve your reliability of equipment. And then the other thing too is 70B in chapter 9 spells out, follow these intervals. But if you have a run of good luck and you go a couple cycles where you don't notice any issues with the equipment, you are permitted to extend the intervals a little bit and maybe go to a little bit longer interval between maintenance. I know one client of ours that I interact with on a regular basis, they have a pretty good handle on maintenance of their equipment, but it doesn't work for them necessarily to shut down an entire plant every 5 years because 70B does that, but because they're noticing that there's not as many issues with their equipment, they've extended it to a 7-year time frame where they do complete total maintenance of the entire plant. So everything's getting maintained on a 7-year basis, but it's a only because they've noticed that they don't have any active indications or any active um, parts where it has active indications and or where the equipment is in imminent failure. All right, so when we look at the tables specifically in 70B, we're going to see some of the equipment or some of the procedures kind of fall under preventive maintenance, where it's just, it's changing your oil regularly. It's really helping to kind of just routine calendar based maintenance program to kind of keep the equipment up and running. Some of the tests are going to fall under what we call predictive maintenance, where it's, we're taking an IR scan so we can see where we got hot spots and we can kind of try and identify when things are going to be an issue and get up to speed on them. And then there's some stuff that's going to fall under what we call reliability centered maintenance only. It's not necessarily the safety stuff, but we're going to build out this RCM plan that really focuses on keeping our equipment operating at optimal levels and not waiting for it to fail before we come fix it, and making sure that we stay on that high end side stuff. Now there's some other standards that get into the different, RCM is really a higher level of maintenance, and what 70B is looking at. 70B kind of tends to play more in the PM and the predictive maintenance side of things. But if you really want to up the game when it comes to making sure our equipment, we don't have any downtime, we don't have any failure of equipment, then RCM is really where you want to get to. So here's the table, table 9.2.2 in chapter 9 sets out our maintenance intervals. Now notice it doesn't give a specific type of activities that we're going to get into. So we'll see, for things like busways, we do a visual inspection. If it's in condition 1, we're going to do a visual inspection every 5 years. If it's in condition 3, we're going to do it every year. Okay. It doesn't tell us what that visual inspection is looking for. That's where we're going to get into the specific tables when we get to the specific chapters. So each chapter for specific equipment has like 4 or 5 tables in it, but there's 3 main tables. I got one for visual inspections, I got one for mechanical servicing, and I got one for electrical testing. Those are my 3 main tables in each of the specific chapters. And when I come to this table, you see there I've got visual inspection, cleaning, lubrication, mechanical servicing, electrical testing. And if there's any special tests that I got to do that are specified in those chapters, I've got a section for that as well. So that you can't use chapter 9 without also using the specific chapter that it applies to. So now the other thing I want to point out here is this table is based on 3 different types of conditions that I'm going to determine during my equipment condition assessment. So I have physical conditions, I have criticality conditions, and I have operating environment conditions. Now I'm going to look at all 3 of these, and whichever one has the highest, so each one of these gets a 1, 2, or 3. Okay. And then, and once I determine that, or the EMP coordinator determines what those numbers are, then we're going to go back to that table and follow the interval that table specifies for that type of condition. So a condition 1, when I'm looking at physical condition, means it appears in a like new condition, unlike the picture on the screen. The enclosure is clean, dry, and tight. It's securely mounted. All the necessary things are still in place. Interlocks, bolts on the door, all of that stuff. I'm also going to look at previous maintenance schedules to see if anything was identified, and if it was if it was fixed. If there were things identified in the previous maintenance cycle and we haven't fixed them, it's not going to be condition 1. Okay. At best, it may be a condition 2 because I still have that active recommendation or that active notification from a continuous monitoring system or something like that, where I'm going to have to do it at a more frequent or a higher frequency. I'm going to have to look at that. Okay. And if I see condition 3, I've missed a couple maintenance cycles, or I identify something that is in urgent need of repair, then I'm going to be on condition 3, and I'm going to stay in condition 3 until I've done a couple cycles back to back and notice that the problem has been fixed and it's been brought up to original operating condition. Then I can dial it back down. Maybe I can get to a condition 2. Ideally, I'd like to get back to a condition 1, which is going to be the 5-year interval. And keep in mind, though, when it comes to physical, like if I drove a forklift into this equipment, I may deem that as non-serviceable equipment and say, this needs to be replaced. It's not going to be maintained. It's just going to straight up get replaced because it's damaged beyond repair. We need to get it fixed. Okay. Um, and now the second condition, or the second condition we want to talk about is what we call criticality condition. And this is really defined as like, what is its potential of failure of this equipment? Would it have potential to hurt people? And that's what they're really looking at from the criticality standpoint. Um, Now I know this was because I tuned into the first draft meeting for the next edition of 70B a little bit. I heard a lot of discussion around this. One's kind of hard to apply to electrical equipment because if it fails, I mean, we could be looking at an arc flash, and 100% of the conversation around an arc flash is going to revolve around the potential to hurt workers in the area. So the conversation kind of hovered around, well, isn't every piece of equipment then condition 3 if it could cause an arc flash? So there's still some, like I said, I think some improvements to be made on this aspect. We'll see where it goes in the next edition. But basically what they're saying, my understanding of this was that if the equipment went down, would people in the plant get hurt? So if a motor failed, is that going to cause a chemical process to cause an undesired result or something like that? And that's what they look at. That's my thought, or my understanding of what they originally meant by criticality. But it could also apply, like the breaker you see on the screen here. It failed and caused an arc flash, and there was somebody standing about 10 feet away from it, um, and he was injured pretty bad. So that kind of thing can have an impact on the way we approach this stuff, and so we may label that as a condition 3. But if I don't have the real concern of somebody getting hurt, I can assign it a 1 or 2. Okay. And then the last condition we're going to talk about is what we call operating environment condition. Now, this is basically, is the equipment rated to be installed in the environment it was put in? You see the picture here on screen. This was a NEMA 1 panel board right next to a cooling tower with all the different corrosive and things inside that cooling tower. It's also outdoors. This is not rated for that environment, and you can see the result. Okay, so this kind of panel board definitely would fall under that condition 3 because it's not rated for that environment. But if it is equipment that's rated for the environment, and the environment's not that corrosive, not that harsh of an environment, it's indoor rated equipment and it's installed in a nice, cozy, warm electrical room, I'm not going to be all that concerned with it. I'll assign a condition 1 from operating environment condition. But even if it is rated for the environment, but the environment's a really caustic one, like what we have here, or the previous MCC bucket that I had up on the screen, that was in a water treatment plant that was also very corrosive environment. So even if it is rated for the environment, but it's a bad environment, I might give it a number 2. Okay. And just to make sure I'm doing my maintenance a little bit more often than a condition 1. And in that table in chapter 9, it's usually means, okay, we got condition 1 is a 5-year interval, condition 2 is going to be a 3-year interval, condition 1 is going to be a 12-year or a 12-month interval, or condition 3 is going to be a 12-month interval. That most of it, there's some that deviate from that, like IR scans is every year. If it's condition 3, it's every 6 months. But for the most part, the 5, 3, and 12-month thing is what that table follows. And another way we can also come up with intervals is, let's say we have historical data, and this really, like the PM kind of historic way we've done PM work is, like, we know that bearing in that motor is going to fail about every 1,000 hours. So we run it for about 950 hours, and then we put something on the schedule to go replace that bearing. So that we replace the bearing before it fails. We don't have any unexpected downtime, because unexpected or unplanned outages are always longer than the planned ones, right? So we want to make sure we try and nip that stuff in the bud before it becomes an issue. So we can calendarize this and schedule things out when we know it's going to have an expected failure at some set time point, because we've seen it happen when we don't replace it ahead of time. Now, the specific articles, articles. I'm an NEC guy, right? So the specific chapters, chapter 10 through 38, those are going to be our detailed equipment chapters. And so we have like chapter 12 is going to be substations and switchgear. 15 is for circuit breakers, both low and medium voltage. And most of those, just like the NEC does, they'll break it up into, if they have low and medium voltage stuff, they'll break it up into a low voltage table and a medium voltage table, because those types of equipment have different requirements, right? So I don't have to do some of the things I have to do, especially when it comes to circuit breakers or something like a transformer. um you know I'm not checking the insulating oil in a dry type transformer on 480 volt system, so I don't need that to be in the same table for my power transformers, right? So those kind of things, they'll break it up into different requirements. They do it a couple different ways throughout the different chapters. And then they also have some reserve chapters in there as well, to kind of say, look, we know that this stuff has some maintenance to be done with it. We just don't know what it is. So it's really, they're relying on us in the industry to say, hey, I've got one of those. Here's what we do for maintenance. And we need to submit public inputs and public comments to the revision cycle. And if anybody has any questions on how to submit public inputs and comments, please let me know. I'll share my email and contact info at the end of the presentation. I'm happy to help anybody submit that. I want you guys to write it so it's your own words and your own ideas, but I'll help you submit it. I do happen to know the back way process of NFPA's submission system pretty well, so I can help you get your voice heard. Can't promise the committee will do anything with it, but I can help you get your voice heard. And so like I said, in each of the specific article or chapter, sorry, each of the specific chapters, you're going to see we have tables on visual inspections, we have tables on cleaning, we have lubrication, as well as another one, mechanical tests, electrical tests. And so we'll go to those specific tables. Those specific tables will detail out what each of the individual tasks are going to look like. Okay, and then we take that back and we go to the chapter 9 table to get our interval. Okay. And if there's intervals that are different than chapter 9, they will be in the specific article. I think transformers is one that has that, where we're sampling our oil, insulating oil and stuff like that, to monitor moisture content and see all that stuff and how that's going. So that table's a little bit different than what we have in chapter 9. All right. And so the big question really is, how does this improve our working environment when we start maintaining equipment in accordance with how 70B has got it laid out? Again, 70E makes a big stink about making sure our equipment's been properly maintained in order to consider it in, that normal operation or normal operating condition. Circuit breakers, we base everything in 70E on, when we get to arc flash. Arc flash is about how much current's going to be during the arc and how long it's going to be allowed to persist. So circuit breaker maintenance is a huge part of the conversation, because if we don't maintain our circuit breakers, we aren't doing the proper lubrication, testing them, make sure they trip at the right setting, making sure they're set at the right setting, and we haven't missed something in the engineering study. All of those things are important to bring to the table on a maintenance standpoint, because if we base our arc flash study off of a two cycle clearing time, and the actual clearing time is closer to 20, well, we have a uh, much different amount of incident energy being released in that arc flash than we would if we had been at that 2 cycles. So we need to make sure we stay on top of maintaining this equipment from a safety standpoint, as well as a reliability. But reliability is a big part of the conversation as well. And that maintenance of our equipment is really going to help uh, kind of build a trend in the way our facility is moving, so we can maintain that and make necessary adjustments. It even helps with capital expenditures. We need to be planning for replacement of this equipment and things like that. So we want to make sure we, like I said, document that, keep records of it, and follow the records throughout time, so we know how to move forward with this stuff and when we can make improvements and things like that. And then the last thing I want to talk about here before I open it up for questions is, the concept that performing maintenance on our equipment, obviously reliability and safety is a huge part of the conversation, but serviceability as well. If we're not maintaining our one line diagrams, like I kind of joked around earlier about when I was in a service van and I'd roll up to a location and ask the facility manager about his one line diagrams, and I get that deer in the headlight look. And they didn't have any, or the ones they had were, we had to blow about an inch and a half worth of dust off the top of them to even be able to read them. How does that keep me up to speed with the equipment you've added in the last 20 years if you haven't updated your one line diagrams? And from a troubleshooting standpoint, those are the first place I'm going to go, so I know where the power's coming in, where it should be going. That's like reading basically the blueprint for how electricity flows in your building. And if you don't have up-to-date one line diagrams, it makes it really hard for me to service your equipment, right? Also, it's going to help with the safety of me, who's the contractor or employee who's doing the servicing, right? It's also going to help me document known issues. And when you go back to the 70E conversation, one of those, there's a big part of that that talks about the meeting between the host employer and the contract employer, and talking about how, as a host employer, you have to provide the contract employer with certain information about the installation. Where are the hazards? Is something about to fail? Have you noticed any issues that are coming up that would affect the work being done? So if we're doing a regular maintenance program like 70B lays out, we're going to be able to document those issues, and we're going to make sure that we stay up to date and we can accurately communicate those to the people who are coming in to service our equipment. Okay. And then all of this maintenance is also just going to help cut down on, number one, the amount of times I have to come in and troubleshoot your stuff. But number two, it's going to cut down on the time it takes me to figure out what the problem is. And obviously, these service contractors are coming in to service our electrical installations are going to be really, I mean, that's a time and money kind of thing. So if we can keep our equipment up to date on its maintenance, keeping it operating functionally, keeping our one line diagrams up to date, documenting known issues so we can get those fixed, and keep our equipment at that ideal operating condition that we can get to, it's just going to make everything run more smooth, cut down on time for servicing, cut down on time to figure out what the problem is, and just make it a better all around situation. So with that, I'm about ready to pass it back to Alan here to open it up for questions. I do want to say a couple things first, though. If you have any specific questions about about your installation, or you have anything that is really pressing from a maintenance standpoint, and you want to ask questions, I've got my email address on the screen, or you can pose it here before we break free. I might not be able to answer it today in this presentation, but I also want to just let you know you can reach out to us at eHazard anytime to get your questions answered. And then I also got to give a big shout out to my friends over at OEL to say, hey, thanks for making today happen. Really appreciate all the help that they've been in getting this thing off the ground, and also in helping me in my career over the years. So really appreciate you guys over there at OEL. And with that, Alan, take it away.
Well, thank you so much, Derek, for this fantastic presentation. Before we start the Q&A, we want to remind everyone of the evaluation survey we're asking you to complete. The survey will open in a different screen after this webinar, and your input is important because it does help us improve our future webcast. Our first question, do the manufacturers of electrical equipment reference NFPA 70B in their respective user manuals?
That's a great question. Historically, probably not, because it was a recommended practice. What they probably refer to is more So the manufacturer instructions, number one, are probably going to give you specifics on what you need to do, as opposed to kicking it off to some other document. But the language, if they were to kick it off to something like 70B or NETA MTS, they're probably going to use language like applicable industry practices or standards or something like that. They'll keep it kind of generic, um, and make it so that the manufacturer isn't requiring that you follow 70B. It might change in the future now that 70B has become more of a full blown standard. Whereas like if you buy a piece of equipment and it'll sometimes say right in the manufacturer's instructions that working on this piece of equipment needs to comply with NFPA 70E. Um, but we'll see. I mean, full disclosure, I've been out of the field for a couple of years doing the safety training and kind of thing. So I haven't necessarily opened up the instruction manual on a medium voltage circuit breaker in a while. So not exactly 100% sure what it is, but they're probably going to have more generic language, at least until 70B is a firm grasp in the industry as being the standard to go to.
Our next question, what is the frequency requirement for one-line diagrams when changes are made annually, like every 5 years, best practice, or what kind
Yeah,
of best practices? Yeah.
so that's a great question. Obviously, anytime we edit the system or we add to it or we move things around or change some factors of it, we want to be making those updates to the one line diagrams as well at that point in time. But they're going to put in 70B, every 5 years. We just need to be reviewing it and making sure that the documents are still what the system is. I would love to, from an altruistic standpoint, I'd love to say that when we add a motor, we add a transformer, fill in the blank, that we all the time, every time we go in and update our one line diagrams. And if that was the case, we'd never have to review it. But unfortunately, that's not the case. So we have to review it on a periodic basis to make sure that we're we're still in good shape, right? So when we make changes, we got to make the changes to the one lines, and then also every 5 years, just give it a quick look over and make sure we've got everything covered.
Our next question, in general, NFPA 70 NEC is not applied to be applied to electrical generating stations. The NESC harkens back to NFPA 70 articles 500 through 517 and Rule 127. What about the applicability of NFPA 70B to electrical generating stations and the NESC?
So, so this
If
is
you need me
a
to repeat it, I'll.
no, this is a good
Okay.
one because this comes up from time to time. I mean, we even somewhat have the same question a little bit in the 70E world. I think a good friend of mine, George Cole, did a presentation at last year's ESW on, yeah, we know the scope of 70E, and the NEC explicitly says that those documents don't apply to generating stations or generation, transmission, distribution of electric utilities kind of thing. I mean, it's a little bit different language than that, but paraphrasing a bit, but his question at ESW was, well, why not? why, why wouldn't we? And so, in fact, actually, let me just, if you guys would indulge me here, I have 70B pulled up in my NFPA link here. I can go look at the scope, and the scope standard says covers preventive maintenance of electrical, electronic, and communication system and equipment. And I don't see an exemption that gets utilities out of it necessarily. But it is a standard, so it's written in mandatory language. Um, so yes, it's meant to be a mandatory document. However, it is it is something that they can use regardless of if the NEC or NESC refer to it necessarily. It's a standard that says here's how you build a maintenance program. So if they don't already have their own maintenance programs, and most generating facilities, I would say, are pretty on top of maintenance because um most that I've seen in my experience are pretty on top of maintenance because they exist to manufacture electrons, and that's how they make make their money. And if they can't manufacture electrons, well, they're kind of out of business. So they do a really good job at doing the maintenance on stuff, but most of them are following, manufacturers guidelines and things like that. And they're going to be already above and beyond what 70B requires. But if they weren't following manufacturer's instructions, absolutely they could apply this. And until we have a body like OSHA specifically say, okay, meeting 70B would meet these maintenance requirements in OSHA. 70B is still going to kind of play in that kind of mandatory but non-mandatory world, where you can follow it no matter where you're at, but nobody's mandating you follow it quite yet.
Looks like we have time to squeeze in one more, or if
All
you
right.
would mind to squeeze in one more question.
Yep.
Is there a firm rule on when you can move from condition 3 to condition 2 and from condition 2 to condition 1, or is there no kind of prescriptive language in the standard as of yet?
So the best thing to hang our hat on there is going to be looking at how they define condition 1, condition 2, and condition 3. And talking about having missed a couple cycles or having, more than one active indication that that there's a problem would put us in condition 3. So we got to do maintenance and maybe go through a whole cycle or maybe 2 cycles where we don't have those indications. We don't have those warnings from the monitoring systems and things like that. So we get a couple cycles under our belt, and in basically it's like, do the job you want to have, right? So get it to act as condition 2 or condition 1 for a couple cycles, and then you can shift it in your assessment. But it's 100% subjective up to the equipment owner when it comes to that stuff. So they're the ones that the equipment owner is the one that has to make that decision. And just like with 70E, it's the employer that has to make the interpretation of how they want to apply it to their facility.
Well, thank you so much. Unfortunately, we have run out of time today. Thank you, everyone, for your questions. And as a reminder, unanswered questions will be forwarded to today's sponsor. Thank you so much to Derek Vigstall, the entire team from our sponsor, OEL, everyone at eHazard, and of course, all of you who joined us today. Take care and have a safe day.